When we integrate, there are two very powerful methods, namely by parts integration and substitution. Let's start with the by parts. Unfortunately, while we have a formula for limit of sum, derivative of sum, and integral of sum, or difference, we have no nice equivalent formula for product. And this is slightly more complicated. If we write once again the derivative of the product of two functions, u times v derivative is u derivative v plus u v derivative. Then if we subtract one of these two terms and change the left hand side and right hand side, we have u derivative v is uv derivative of that minus uv derivative. And when we integrate, then integral of the derivative can be written as uv alone, and we have the formula that integral u derivative v is equal to uv minus integral uv derivative. And this is a very useful formula which is called by parts integration. Why is it called by parts? If we have a function that is a product of two terms, then first we must look at u derivative and we find u. This is integration. We are looking for the antiderivative of u prime. So this is the first part. Then we write something and we build this integral. And we must once again integrate. So this is the second part. So one part, second part, by parts in two steps. Let me introduce this, how it works. Imagine we have integral, and the equivalent formula is, if we interchange u and v, then we can have uv derivative integral is uv minus u derivative v. This is equivalent. You can think of this as integral of a product where the prime is at one part is equal to uv with no primes minus integral the same functions, but if here the second was with prime, here the first is with the prime, and if the first was with the prime, then the second is with the prime. So some prime mover. You move the prime, we move the symbol for derivative from one side to the other. Let us illustrate this with some example. Say x e to x dx. First, we must choose whether we use this one or this one. What will be easier? In many cases, one of the two choices helps a lot, and the other makes things more complicated. Let us see both ways. If we choose u is x and v derivative is e to x, then we prepare u derivative, which is derivative of x, which is 1, and v is the antiderivative to this one, which is e to x alone. So we have uv, that means this times this, x e to x, minus u derivative v. So if the terms here are on the upper line, then the terms here are on the lower line. So we have minus integral u derivative v, which is 1 times e to x dx. But we don't have to write 1, and integral of e to x is e to x. So the result is x to x minus e to x plus c. We can check the result. If we take the antiderivative and we differentiate, then we have x e to x minus e to x plus c derivative of that. Here we have a product, so derivative of x is 1 times e to x plus, we copy x and differentiate e to x, which is e to x, minus e to x derivative is e to x, plus c is 0. And now the first and the third term cancel each other. We don't have to add 0, and we have the result x e to x, which is exactly the original function. So it's okay. Now, what happens if we choose these two functions in the reverse order? What if we try this? Integral x e to x dx. And what if we say that u is e to x and the derivative is x? Because in the product we can swap the two terms, no problem. Then u derivative is e to x and v is the antiderivative of x, which is, yes, x squared half. So this is uv, which is, let me write x squared half first and then e to x, minus integral of the terms on the second row, which is x squared half e to x dx. This is correct. This is true. But it is not very useful. You see, here we want to integrate the product of a first order polynomial times exponential. And we have converted this problem into a problem of integrating second order polynomial times the exponential. This can be integrated, but we would do this by converting to this and by this way. So this is correct. There is no mistake in the sense it is true what is written here, but it is not useful. We don't like it, we don't use it, it's useless. So if you start using by parts integration and you end up with something that is more complicated, a good idea is to try to swap the u and v change. So this is the correct way and it leads to the correct result, which is easy to check. So that was the by parts integration.